We have to have him in our class and want to learn from him.
All right, thank you. So I did do a presentation because I'm in the middle of paper, and so that's due at the end of the month. So I want to thank Dr. Khan for allowing me to come. I always have tried to be supportive of the Jackson State Engineering, Civil Engineering Program and engineering program as a whole during my tenure at the city. My background is very diverse. I graduated from the University of Mississippi in 1996 with a bachelor's in civil. And I proceeded after that and obtained a master's degree in soils and pavements from Mississippi State in 2000. At some point, I thought about going into consulting, and so an older engineer decided or gave me some advice that I may possibly want to get a master's in business. And so I got an MBA on top of that. And so I got that locally here to Belhaven. And so back around, and I was through school. I was through. And so around 2006, I had an opportunity to meet Professor Dr. Gibson at University of Alabama. And they were in the process of recruiting PhD students. And so he proposed a topic, and I was like, I don't know about that. And so we got to talking a little bit more. And so there was one little thing that that kind of was going to be a hindrance was at that time, and I think it still do, they require you to stay in your own campus. And so I was like, how am I going to do that? You know, I had a wife, I had 2 young kids, they were on the age of 5, and so how was I going to manage that? And so we came up with a plan that I would drive over to campus twice a week. So I would get up at 4 o'clock in the morning and drive 3 hours to Alabama and take classes and then come back home. And I did that twice a week for a year. So as you can see, you gotta have some dedication to do that. So with all of that work being, with all of the travels and everything, I was able to graduate in 2013 with a PhD in civil. And so, yeah, I'm done. There's no more after that. So, but my academic work did help me with my work at the city. I worked at the city for 20 years, and prior to that, I worked at MDOT for 4 years in the geotech lab. And so all of that experience in academic work plays a big role in what I do at Earth, and I'll get to that in a little bit. But I want to express to you that the need for civil engineers, okay? One thing that was constant throughout my career was the challenges that we have in infrastructure, right? We read about it, right? We're constantly seeing on the news, you know, especially in many urban cities, challenges of infrastructure, okay? Whether it's water line, whether it's sewer. We've seen continual mandates that have come from the EPA, right, as we deal with water quality, City of Jackson, right? We're dealing with sewer. It's aged, right? We have discharge that are leaking into our rivers and streams, okay? It's not supposed to be like that. We have bridges that are over 50, 60 years old, okay? We're now incorporating into rail, especially on the military side, okay? We're seeing it more even on the private side, Amtrak, you know, CN. They're constantly looking at innovative ways to improve their transportation needs through rail. And so all of these are challenges that civil engineers have to come up with unique ideas in order to meet those challenges. And so we need men, we need women who are willing to step up and face these challenges, because these are not today's challenges, right? These are challenges that are going to exceed well into the future, well past my lifetime, and well into yours. And so building bridges is part of that process. Unfortunately, when I retired from the city, I really had nobody to hand off the knowledge that I had about the city. Um, they are struggling right now, okay? But it's not just Jackson. I was talking to Dr. Khan. There are a lot of urban cities, especially in the South and in the North. You know, when we talk about municipal government or municipal engineers, there's a need. There's a need in urban. We're constantly looking for engineers, whether you're mechanical, civil, you know, because the military has needs on the military engineering side that are basically dedicated to the warfighter. Putting the warfighter in the best position that he can, that when there is a need for the military, whether it's the Air Force, the Marines, or the Army, they have to go to a certain area, right? They got to be able to get there, okay? Aircraft, okay, you know, we look at commercial aircraft when we fly, right? Okay, well, think about that on the military side. C-17s, F-15s, these are large aircraft, huge tire pressure, right? And a lot of weight. And if they have to go to some distant island, you know, to deliver goods or whatever, they can't put that plane somewhere where it can't land and then it can't take off, right? It puts that military, it puts that warfighter in a bind. It puts him at a disadvantage. And so those are some of the things that we do out in urban. Is primarily we meet the need of the warfighter, but we can't do it without you. Can't. And so there's two needs, right? There's municipal and there's military, right? And so I implode you that as you start to look at what I want to do when I leave Jackson State, these are two areas that I think that I would suggest that you strongly look into. Number one is rewarding, right? A lot of times we want to look at how much are they going to pay me, and that is important, right? But there's also too, you want to love what you do, right? Think about it. How much time do you spend up here every day at school? Yeah, you must like it, right? Because you wouldn't come up here. It's easy, right? So just think about that as a job, right? Think about, I want to do something that I like, but I also, you obviously want to be compensated for it too. But don't kind of sit beside, okay, well, you know, I'm just doing it because I want to get a check. No, you really want to like what you do, you know, because number one, you feel good about it. And also two, you're helping the profession, right? You're helping those who have a need for improving their infrastructure. And so, my tenure at the city, I had some challenges, you know, we endured quite a bit of criticism, you know, and it happens. But at the end of the day, we serve the community because we're in a role of servitude. And we use our technical expertise to assist the community where they have need. And so those one of those things I would say would be rewarding. Where I'm at now, okay, I work in the airfields and pavement branch. We evaluate airfields. We look at distresses that are on airfields. And then we determine how do we correct it, okay? the important part of that is that we do a lot of manual inspections. Okay, and so it's kind of still like paper and pen. You know, we have a list of distresses that we look for, and then we check it off. When we're looking at new software that's available, how many of you heard of PCI? Okay. Well, PCI is a pavement condition index, okay? And you know how we think of Google, right? And we think of mapping, okay? Well, like for instance, in Jackson about 2 years ago, we had some people, some consultants come in, and basically they had a van, and they went around the entire city and they evaluated all of the streets. And they gave us back a PCI. And the PCI ranged from 100, that was good, and 0, that was bad. So you know what Jackson was, right? You know, like way down there, okay? There were a lot of zeros, there were a lot of tens, you know, there were very few anything above 60, okay? So, but that's what we do. In context, that's what we do. But we do it for the military side. And so, but we're looking at different software, okay? The Navy has funded us around $500,000. And in this software, we're trying to get the software to mimic what a person or an experienced inspector will look for. And so it kind of falls in line with AI, right? I'm learning more about AI every day and what its capabilities are. And so at some point, we are trying to get this software to mimic, like I said, what that expert who's probably been doing this for 20, 25 years, you know, what he can see out in the field. But still, there's some subjectivity that comes with that, right? He may not feel good. Like for instance, we went to Colorado Springs this year at Fort Carson, okay? It was hot, all right? And by the end of the day, I couldn't tell you what was a crack and what was not a crack because I was tired. You know, my eyes were tired, everybody was tired because we've been out in the sun all day. And so if we have the ability to have a van and it can, if I say that it is a low horizontal crack, right, in the pavement, and if the van can say it's a low horizontal crack, then guess what? I can depend more on the software that has less subjectivity that can meet, you know, that can do the inspection and give me somewhere between 5% of an error of what I would see manually, right? So those are some of the things that we are looking at in our branch. Also, too, we have an asphalt lab, and we also have a construction lab. A concrete lab. And we do a lot of testing on asphalt, and we do a lot of testing on concrete. Primarily what I do is, I have a program that I oversee that we look at surface defects on airfields, which are called SPALs. And they're at the top, upper 1/3 of that pavement structure. And you might say, well, why is this such a big deal? Well, if you have billion-dollar aircraft that are taking off, and these little spalls that are little divots in the pavement that have loose material, you'd be surprised what that loose material, if it gets into the turbines of the engine, it can cause havoc, right? And so the airfields have to be clean. They cannot be any what they call FOD, foreign object debris, on the pavement, because it can cause those aircraft to malfunction. And so we just can't have that. And so my primary role is really to look at rapid setting cementitious material. You know, I kind of describe it as, you know, we all go to Home Depot, right? and we go and pick up quick free bag, right? All right, now, how often do we read the directions? Huh? We don't do it, right? We get it, we put it in a wheelbarrow or a bucket, right? And what we do? We add water into it, it just looks like it's ready to go, right? Okay, and then we pour it. We put it in the mailbox or whatever, and we call it good, right? And as long as that mailbox is sturdy, what we say, oh, it's good, right? Well, we can't quite do that, all right? Because here's the deal. Water with cement and rock can be good and it can also be what? Bad, right? Too much water, right? Okay, so we follow the manufacturer's requirement between the water cement ratio, okay? But we also have to look at the fact that, hey, if a soldier is doing this work, right? Okay, what is he gonna do? He's gonna do the Home Depot method, right? All right, okay, because he's like, I just want to fill this up and get back to doing what I'm doing. And so we have to look at it from that aspect too. Okay, and so when we're doing our testing, we have a laboratory process that we do, and we use ASTM methods. Okay, so we look at compressor strength, we look at flexible strength, we look at bond strength. Okay, we also look at time of set, modules with elasticity, and also too we look at slump. And so we have parameters that all of these potential products have to meet. And so if they meet our laboratory protocol, then they go on to a qualified product list for DoD installations to use. That's really important because the last thing we want is to certify a product that doesn't meet the criteria because it could cause a mission to fail, right? When we need that particular product. So we take a lot of pride in this program. The Air Force funds it every year, about $350,000. And so from there, we do the evaluation. We're testing 6 products right now. 3 of them are quick free. And so, when I say that I like what I do and I have fun doing it, I do. I really do. And the uniqueness is that all of the people that I've worked with, they enjoy what they do. The new challenges that come with the job, but also to just learning about different things. You know, I'm the type of person that I don't like to get set. You know, well, some people like asphalt, some people like concrete. I like them both. All right, and I like gravel roads. You know, I like it all. And so I like to be diverse in that aspect. And so I think that's just from working at the city, it's kind of transcended over to me working in Earth. But like I said, I just wanted to kind of give you guys and ladies a snapshot of the possibilities that are there. And you know, at some point, me and Dr. Khan, we're gonna be working together. We tried to work together at the city, but we couldn't make it work. But there will be some opportunities, and I hope I get a chance to come back. And I don't have a presentation at this time. And hopefully that I'll be able to show you some of the work that I'm doing in sustainability. And because we really are going to have to start embracing climate change into and integrating it into civil engineering. A lot of the literature that I'm reading right now is a cookie cutter approach. Okay, and I hate to say that, but we're kind of mimicking what somebody else is doing, right? But the things that we really need to look at now as far as challenging is that, first of all, the United States is really regional, okay? You have the Northeast, you have the Northwest, you have the South, okay? And so you have the East Coast and you have West Coast. And so when you look at that, and you look at temperature difference, right? Okay. As far as you go up north, you're going to be more exposed to freeze thaw. Okay. If you go west, west, okay, you're gonna have a lot more rainfall, right? Okay. Go further south from there, you have droughts. Okay. And in the south, well, this year, limited rain, but we have very seasonal temperatures that can range from 80 degrees one day, right? And like last week, we were freezing, right? Okay, so that plays a role, okay? It plays a role in how we design. It plays a role in our selection of materials, right? That we use, and for instance, on airfields and pavements, okay? And so it also determines whether we'll use a flexible material or rigid, right? And so we're playing that with climate is a big role that has to be introduced in how it's impacting the environment, right? Some of the materials that I'm researching right now, you look at recycled glass, recycled aggregates, we were using at one point somewhere between 30-35% wrap in some of our overlays. Well, that was good. We were getting a benefit as far as cost because we didn't have to transport it off, but also too, we probably saw some reduction in greenhouse gases. But the other aspect of that is I didn't quite see the performance. Okay, and when performance, we want our pavements to perform for an extended period of time, right? But what I was seeing is once we did our overlays, we started to see a lot of premature cracking. Okay, especially if we did some pavement in the spring or the summer, and then we went through a winter. Okay, a lot of the pavement was cracking, and so we started to say, okay, well, is it a mix? Or are we using too much wrap? Do we not have enough virgin materials in there? Is it the asphalt? Or is the binder? I mean, is it just not together? And so the need for now is we need data. We need data. Okay. That's the other thing that is lacking in a lot of this literature when we talk about sustainability in pavements. There's not a lot of data, and so one of the findings in my paper is that you need money, but we also need data. We need to really see how implementing sustainability as far as in paving, okay, can we still achieve performance out of our pavement structure moving forward? And what is that going to look like? Okay. And so what I'm hoping is that we're really digging deep into this on the military side. And so the military has come up with this adaptive plan, but there's a couple things that's missing: funding and data. And so they want to be zero emissions by 2050. Okay.
2050?
2050.
Okay. Maybe 2050 doable. If 2030 is possible.
We'll see. But I still think that when we talk about pavements, we're going to have to look at data, which means we're going to have to do demos, and we're going to have to fund those to see how these sustainable materials. Okay, because it's kind of like I posed this to one of my coworkers. You remember how when we started recycling, right? And everybody wanted to recycle because it was what? Trendy. Yeah. Right? Okay? All right. But there were some people that were definitely recycling, and then there were some that were like, the little green bucket that you had, they used it for, gardening or something. It never wasn't, they were never intended to use it for recycling. So, but the benefit of recycling is, when we look at our landfills, right? We're increasing capacity because we're not putting large bundles of plastic in there. Okay. When we look at sustainable materials, whether it's recycled glass, recycled scrap, or recycled aggregates, these type of things, we gotta determine, right? And we gotta show that it is a benefit and that we can get, we're not doing sustainability because it's trendy, we're doing sustainability because we can get performance out of our pavement. And so I will end it at that. I would take, if you got any questions for me, ask. And if not, I'll ease on out, but I appreciate you, taking the time to listen to me. And Dr. Khan has my information, if you have any questions or you have any suggestions or whatever, feel free to contact me.
Question?
I have a question. So, you were saying that you are working with the airfield pavement or something. So we cannot change the airfield pavement in the night, right? So how you are actually integrating the climate change issues with the existing infrastructure?
So are you asking me how can we integrate that into our current infrastructure?
Mhm.
So that's going to start with just really maintenance and rehabilitation. Okay, using certain materials, and it could just be for patching. And so let's look at it from let's just say that we have on our airfield, we have an area where the pavement has cracked. Okay, and the only logical solution is that, hey, we can go in and do a full depth patch. Okay, so we can look at bringing in some new materials, right? Or we can look at maybe some recycled materials that we can put together. And let's just say it's a concrete surface, okay, for the cement. Okay, and so we look at several different rapid setting products that says and say that, hey, within 2 hours, because one thing that we have to look at also too is we gotta be open. We can't have a significant amount of downside, okay, because we have a number of traffic that has to come in as far as aircraft. And so we're looking at a rapid setting product, and let's just say that that rapid setting product is using recycled aggregates, okay? And those recycled aggregates are combined with natural cement and then maybe some sand. So it'll be like a mortar mix, okay? And so if we do the full depth repair with that particular mix, and then we'll determine from there, we'll test it for compressive and flexible strength and see if we can get the type of strength that we need in order to get that airfield back open to traffic. So that would be one way. The other is just completely looking at future designs. Airfields have a limited life expectation. But the next time that we come up with a design, if we have the data to show that, hey, these are a list of sustainable alternatives that can be used, then we can utilize it from there. Because overall, we're trying to reduce CO2 gases, right? And so we have to look at different ways that we can do that. We know that we can probably, this will also decrease transportation costs, limited equipment on the airfield. So all of these type of things, which also too, you can look at reduction of fuel. So all of these things play a role, but I think we have to be creative. And, to be quite honest with you, the military is a little bit resistant, right? They like things the way that they've been doing. And it's no different from DOT. I mean, it's hard to get a DOT to change that red book, especially here. So, they have specifications. The military has specifications. They have a uniform facility guide, and then for specifications, and then a uniform facility for horizontal and vertical construction. And so, we're actually doing some updates now for, patching. And, we know that once we get done with updating the drawings, it's gonna take it's gonna be a challenge to trying to get those drawings updated because it's just, it takes time for, not everybody likes to change, right? They like some things staying the same, but, if we want to achieve outcomes, that are beneficial to us, then we have to make some change, but they have to be good change.
I have a question. So, for the airfield pavement, what are the criteria that you are always testing the pavement for the C-17 aircraft or any other thing that you always can use? One question is that. The second thing is, we were saying about the recycled materials or some sort of stuff, right? So, the impact of the C-17 aircraft is already been tested for the recycled materials or it's in the very vintage stage? It's the very early stage.
So, to answer your first question, yes, we're always looking at how aircraft impact airfields, whether it's flexible or rigid, okay? Because we have to determine the number of passes that our aircraft can make on an airfield before it fails, okay? The military looks at that as and see if they have to go to a mission, okay, and they have to complete a mission, all right, and they have to bring aircraft in for supplies and also for troops, okay. If they're going to be there for an extended period of time, and that runway is the main way in and out, it has to be able to hold up. And so when we do our demos, we look at that, right? How many passes can this runway make before it fails? So we want to be able to say to the Air Force that you got between 4,000 and 5,000 passes before it fails, okay? And what that does is that helps them as far as determining the time that they have to utilize that pavement. And also it allows them to strategize, right? Okay, and so that's one caveat. The other is, all right, what do you do before it fails? Do you have an opportunity to go in and patch some areas, okay? And so if it's an active runway in and out, you can go in and do a full depth reconstruction, right? You gotta have something that's relatively quick. And that's when we talk about rapid setting. And so we evaluate those rapid setting products. We do it on a small scale for small. We also do it for large, called crater repairs. And so we want to make sure that we have a list that's available that can get there and make that repair, and so that airfield can get back open, because they may be able to get another 2,500 passes if we go in and make those repairs in the airfield. And so it's all about trying to get to meet the mission requirement for the warfighter. That's the top primary goal. And then the other question you asked was about materials, right?
Yeah, about the recycled materials. Actually, I will be adding another question with that because you are talking about the sustainability. So, is there any study that that has been done on when the aircraft pavement has been repaired with the regular material and the recycled material? So, what is the sustainable period of that?
No. So that's what we're going to be looking at.
So that's the future.
That's the future. Because remember I was saying how we need data? Well, we need it. And the part of that will be doing the demo work for that, right? Coming up with different mixes, whether we're using recycled glass, crushed brick, recycled aggregates, these types of things. How do they perform when in these type of active sites? If we and what is a good mix, right? And so it's no different than mixing asphalt or concrete with virgin materials. You're trying to determine what is the best mix for your particular, outcome based on what your intended purpose, right? So it's the same thing. It's just now we're saying, okay, what if we don't virtual materials, right? And so if I go to, Guam, okay, which we're doing active work down there, okay, and I can't get wash gravel, or I can't get pea gravel, or, what if it's not there, right? I've got to find an alternative source, right? But at the same point, we're trying to what? Reduce greenhouse gas, CO2. So we're trying to meet this criteria, but also too, at the same time, we don't want to meet one criteria and then not have the performance side of it. We got to be able to balance that. And so that's why I was saying that we're going to have to we're going to need data, and this is going to require more research work, right? And so it's going to take some time. But I feel like that if we emphasize it and we put some funding toward it, I think we can find some solutions to the problem. But whereas we want to see greenhouse gas reduced because we know the effect that it has on the climate, but at the same time, we don't want to focus on we need the pavement to perform to our expectation.
I have a question, Dr. Ring. It's a very good discussion. I love that. And so basically, if we the alternate methods so far on the market we have is mostly comes from like a bacteria-based solutions. Whenever we are trying to use the bacteria-based solutions, the theory works, but the applicability is not really at all. Even my personal feelings is it's not even 5% ready to what is needed. So, for example, like the MICP technique, which is being used, that uses a chemical called calcium chloride. About 50 grams of calcium chloride costs like $50. But there are other ways of doing that, and I haven't seen like there's a gap between that research versus the experience. And for a person like you, it's the opposite. You come with the experience and now you're in the research, so you can add lots of value in it. So in this case, like we see like there are some source of organic material, especially in terms of adding from the seed bed or seed flow, like the seed, and coming up like some of the solutions we did trying to make sense. I know like some agencies trying to build this with the great materials, and it has some challenge with it. So how do you see it? Like, does it have any kind of application in terms of the architect or any other aspects of that?
I think it's gonna go back to data collection, right? I mean, so it's kind of like you're at this point and you have the realization that, hey, okay, I'm kind of here, but I want to be here. And so how do I get here, right? And so in our world, it's through research, right? And so, and it's through data collection. So you have to have, in order to get data collection, you got to have samples, right? And so that's where we're limited, the sampling part of it. And so we have some funding, which is a good thing, right? But the question now is, okay, what do we put in the sample pool, right? And I think that's the same case with you. I have some ideas. There's some other ideas that come to play. I kind of got involved with the sustainability because the craziest thing is we had this huge pot of money and nobody in the branch was like wanting to tackle it. And I was like, okay, well, if you all don't want to use it, I'm gonna stick my hand in and give it a shot. But in this case, I think that comparable to that would be the biofuel, right?
Yeah.
we had Mississippi State now working with Dr. Howard and, Dr. Hodo, Wayne Hodo is doing a lot of that. But, you know, he is struggling with like, okay, I don't know, there's more work that needs to be done, right? And so the challenge is trying to articulate that because you're gonna need more resources. And so then you gotta dictate, okay, well, what does that research want to look like? Because it's gonna be different. It can't, we kind of met this challenge, right? So we now we got to move forward. What is it gonna look like? And so it's kind of like where we're at now. You know, I was saying that there's a whole lot of literature that, hey, greenhouse gases, the first thing you see is either it talks about, you know, Biden's, act, or it says, you know, well, we gotta, reduce climate change because of this. And that's great, right? But how do we move on beyond that talking point? And, you know, the next emphasis is we gotta do research. We've got to take the next step and say, okay, here's what we're gonna look at. You know, we took, you know, there's the life cost analysis, you know, these type of things, which is great. And we do the same thing with payments, right? We do the same thing with payments, and that's great. And it's a good tool, but I think that we need to look at it from a different perspective in that we say we have the tool and we can use the tool, but we still missing the research and the data component of it. And so I think if we can further our research with, and keep enhancing the tool, I think we'll start to see that, okay, we can say that, hey, this material right here, all right, it's good. It can be utilized for this, and this. And obviously we can say that we're helping the environment because we're using maybe less virgin material in certain aspects, but we're also achieving performance and CO2 reduction, right? So we're limiting the environmental impact, but at the same time, we're also seeing performance in our paving, which is what we want, right? Because one thing that is that connects all the dots is that there's not going, in order to address CO2 reduction, we're not going to reduce pavement, right? So we're not going to take out Lynch Street, okay? And say, in order to reduce CO2, we're going to take Lynch Street out, right? We're not going to do that,
Sure.
right? Because then when it rains and you're going to need a four-wheel drive to get the Jackson State, where we're benefiting, right? And so we need pavement structure. It connects us. It allows us to go to work. It allows us to go to school, church, hospitals, you know, food, recreation. And so we're not going to reduce that. So we have to find a way, right, to find alternate paths, right? Because it connects us.
I see that. But it's a really great that you started looking into the sustainability, and we also have some work, and we are continuing our work on the sustainability, and hopefully we'll have a strong team up on that aspect too.
Yeah. And you know, like Dr. Khan said, I'm looking at it from a totally different angle, more from a practical side of what we can do and what we already have, right? And so there's opportunities there. And so we're going to really explore what those opportunities are. And so hopefully over the next couple of years, you know, I can start doing some real demo work and starting to see what some of these alternative methods, what can they really do, you know? And so, because I think it will play a larger role on a big scale if we're able to see exactly what they can and what they cannot do. So when we start strategically saying, okay, yeah, here's a framework for reducing the carbon imprint, and this is how we do it. One way, right? There may be multiple ways, but you know, we always want to try to find one way, and then we can find others.
Absolutely. But the best part is the movement already been started, you know?
Yes.
So since we started the movement, it will continue.
Yes.
One last question from my side.
All
How you are enjoying the transition?
right. You know, I'll be honest with you, it was a difficult transition the first year. You know, I really, enjoyed working at the city, but I knew that it was time to make a change. And so that's part of life, you know, change is a part of life. And so, you know, you'll change too, right? You won't be here forever, you know, right? And so, but the next step that you make, right? You know, you will make a step that will benefit you and your family. And, I just, you know, I would implore you to look at it from an advantage that, I want to do something that I really love. And that I can get some fulfillment out of. And I can get compensated for it. And so, and that's where I'm at. And, you know, I have, the craziest thing, I wrote, so the two conferences that I'm going to next year, the first paper I wrote, and I'm getting a review, you know, I wrote it in a week. For the sustainability paper, it's, I'm having to like start on it and kind of take a step back, because what I'm finding is that there's just not a lot of supporting documents, right? It's not like data. And so I'm having to kind of quantitatively write this in theory, right? Of what we propose and what we think we should be doing. And so I'm backing that up with is that from a practical standpoint, we gotta collect data. And so one of the findings for me is, how do we do that at the end? And I know it's probably gonna turn some people off, and I hope the paper gets accepted, but I think that we have to sometimes look at look at it from a different way or a different angle. And so this job allows me to do that. And so I never thought I would be doing research. You know, it's a little bit of a 360, but I'm actually able to use my experience of being a working engineer. It's helping me as a research engineer, look at things just from a technical and a theoretical approach, and then trying to combine them together for an outcome. And so, but yeah, but I like it. I like it.
Especially the experience you being on stage.
Yeah.
That really helps, because many cases, my experience is when we think from the academic perspective, in academic, there are like different groups working on it, right? And if you look at the way it started, especially in academia, it started like from their early career, they started jumping into the academic world and missing the experience. And when the experience is missing, we try to be fancy. We try to look at the problem in one aspect without looking at like how we implement that. You know, we just like try to just dive in. But here I really feel like the experience is very crucial, because we will know what to try and what not to try. Because it's like the perspective is far more important than just only trying a idea. You know? So, and your contribution will be significant on that aspect.
Well, I appreciate it. Hope y'all enjoy the rest of the class.
Thank you so much.
All right. Take care.
What is that?
Yes,
I'm here. Yes.
I didn't hear anything from you.
Yeah, I hear the whole discussion.
Okay, that's good. All right, so what do you think about his presentation?
Who, me?
Everyone. Can you see me?
But I thought he would go more in details, but he was very brief in points talking about choosing materials, recycled materials for enhancing the technology or like for the airfield pavements and all that stuff. But he did not go in depth, like how they kind of come up with those materials, how come they can like choose those mixes, how they calibrate it, how they go. So, I mean, that was good as a highlight, but it was very general. That's my thoughts.
Give an overview, basic overview of his work. I get that.
Yeah, I actually was expecting before when you told us like a guest lecture, I was expecting some like long lecture with a lot of details and going like if you remember the guy from MDOT, I forgot his name, Mike.
Yeah, Mike Stroud.
Yeah, his presentation was actually more details and more in depth than this one. But this one is good. I'm not saying it's not good, but yeah, it's I was expecting the expectation was that's the thing.
A very interesting guy, because like he has done MBA, masters, then PhD, everything he has done.
Yes, and his job was really tough, you know. His job was really tough, and then he, because City of Jackson is well, in terms of like that lacks a resource. He is the person on he's the person always to be blamed for, but he don't have the resources and the capabilities from the city to fight all the problems. That's why it's like you was mentioning the pavement condition PCI, right? So in terms of the PCI, PCI is basically you rank pavements, right? So in terms of the PCI in Jackson area, you will see most of the pavements are like in poor condition, and that's very normal. But most of the people also ignore the few other aspects in this too, you know. So anyway, that's a different discussion. Let's go back to our demand flow. Okay.
So from the pavement in the jurisdiction of DOT or city of Jackson?
It depends on who owns what. Pavement is not always the jurisdiction of the state. It also the jurisdiction of the city and county. You know, so because if some of the roads are owned by the county, some of the roads are owned by the city. And all the highways, interested and the state highways are jurisdiction of the state highway. But other than state highways, like if you look at the Lynch District, who owns that? MDOT? Absolutely not, right? So the Lynch District is within the jurisdiction of the city of Jackson. But if you cross the Lynch District and look at the roadways inside Jackson State, who owns it? Is the Jackson State. Is the Jackson State jurisdiction, not the state. Yeah, is it so?
It's private. So.
Yeah. So it's a state agency. But
based on the state.
yeah. So and it also goes with the water problem. So it's like city delivers all the water, right? And in terms of the water, then it comes to Jackson State. So the water supply depends from the city. But if the water supply depends on the city, then sometimes their supply system collapses, and so there is no water in the Jackson State. So how Jackson State can solve this problem?
That's your own plan.
That's the thing you mentioned.
No, my question is how you can solve the problem. Any idea?
Their own ecosystem.
Make a modular system like private system for the Jackson state or something like that.
There is a way, and in this case, I'm a very big fan of the model in Bangladesh. You know? What happens in Bangladesh? You have a water supply system problem? Do you have a water supply system problem in Bangladesh?
Always,
It's absolutely.
every city.
Every city, or everywhere, right?
Unless you are supplying the water.
If you take water from Wasa, then there
Then.
is definitely, otherwise you have to put a tube well by yourself.
So basically, you are collecting the water on your own,
Yes.
okay? And you are making the arrangement of your water on your own. So how you do that? You just add a reservoir. Underwater,
But it's not a compatible system.
underground water reservoir.
This system is collapsing because if you see in Bangladesh, what they are suffering right now, all the big cities or the prime cities right now, they are having a scarcity of groundwater table. So, in Chittagong, if you go in Chittagong in in Dhaka, so there were, some locations, you have to dig deep up to 140 or 160 feet for finding a water. So there was no regulations, people are.
No,
doing their own stuff.
you are mentioning about the groundwater table. I'm talking about the system, the backup system. In Jackson State, add a backup system of adding a water reservoir, like for 3-day reserve, 6-day reserve system. That will primarily solve the problem, right? You keep it operational, but to do that, you need money. Anyway, okay, so in terms of our course, have you watched the lecture video?
And that is finished.
Half of the video? So,
Swapna, I have a question.
Sure.
So you are going to discuss today
yeah, you
about
can live.
standard procure
Yes,
today?
okay.
So then I will be here.
Yeah, that's my only last discussion, then I'm done with the course. So before I go there, any question on that? No question? Okay, so when you are presenting the project presentation, when is the project presentation? Kelechi, when is the project presentation?
Oh, 14th. 14th, right?
Pardon?
Okay. No.
Sure? 14 is next week. Yeah, you have the only option is either 14th or 28th.
We are not gonna commenting on that.
Anything's fine.
Okay. Fourteen or 28th.
48.
That's fine, only. Yes, my presentation for the proposal is November for.
Yeah, your proposal is going to be December 4.
Either.
Not in this, not in this.
So Omar, when is the project presentation? 14 or 24?
Well, for me, I think I'm good for both 14 and 24.
28,
I mean,
there's no 24.
yeah, I'm fine with any.
I don't want to ruin anyone's Thanksgiving time. Yeah. But it's gonna be really tough for you guys. I guarantee 27, you are presenting on your thesis, and then on 28, you cannot present this. And then you're leaving on 28 night and taking the flight on 29, 28.
Like 29 morning we can do it.
So when is your plan? In 29?
Is, 8 in the evening, so we can leave at 4 or 5.
So when is the flight?
Evening,
What?
5:20.
5:20 means you need to be there by 3.
We can start from like 6 or
That's
5.
international, by 2:30, right?
No, 3 hours. You need to be there, 2 hours, 2 hours span. So 5 minutes, 3:30. Oh, 2 or 3.
In the morning, like 5.
No, it's bad, that's very bad. I promise. Because, if you get stuck in a traffic. I did that, that's why I'm saying it. It's really, really tough. I barely get into the plane. I was the last person to check in. No, it's like, they already shut down their counters. Yeah,
I was the last person to check in when I went to
last person to check in.
I was the last person.
Yeah, so it's really bad, and I had to drive really, it's a tough drive. I did that, you know, so. Anyway, I don't recommend that, but it's up to you guys, so, 28, I'll stick with it. Okay. The only thing you cannot buy is time. Okay, anyway, anything else? Anything we need to discuss? If not, then our course is done. I just want to discuss one more thing. On the output dam and slope discussion. But make sure you watch all the videos. The videos are really important. Because in the final, there will be problems related to that, for sure, you know. And the time you're gonna get is not enough to watch the videos and to. Okay. Anyway, so, and also the homework is due, is it next week?
14th, yeah.
Okay, all right, yes, question.
There might be an option. If she presents online,
Yeah, you can do the normal, that's fine.
let's do that.
It means you have 3 groups.
That's fine.
Yeah.
Our presentation will be there.
Yeah, you can do the normal. Presenting online is not a problem, that's completely fine, but how are you gonna do that?
Which you start by before the cluster. Stage.
Okay, okay, that's fine.
So many things. Huge thing.
Yeah, if you start in the morning, then that's good idea. Okay. All right. So, basically, that's the only other thing I want to discuss. Can I draw it and share the screen so Umar can see it too?
From here, we have to share.
There is a whiteboard or something like that.
There is a whiteboard here as well.
Yeah.
Yeah, there is a whiteboard
Allow it from the-
beside apps.
Oh, I got it.
Yes.
Share.
Oh my.
Okay. Good. Can I write?
Yes, I can see.
What is this?
Tap outside, it's gonna go down.
Tap outside.
Okay, all right. So how I can make it full screen?
It's already full screen in our screen.
Okay, that's fine. So basically the things I want to discuss today is the compaction, you know. So for compaction, what is the difference between the compaction and consolidation?
Consolidation is for 100% saturated soil. Sorry, saturated soil. Consolidation.
Consolidation is 100% saturated soil, but what happens in consolidation and what happens in compaction?
In compaction, both air and water got expanded, expulsion of air and water happened in compaction,
Expansion of
air and water,
air and water happens.
and soil become very dense, void ratio become less.
Okay, so in both of the case, we talk about the E. Wow. Okay, that's fine. So we talk about the E, right, in both of the cases. So our E has to be lower, right? So the compaction means we are trying to add a dynamic energy, right? And when you add a dynamic energy, that will reduce the E. That is the primary effect, right? So it can be any kind of like mechanical force being applied on the soil, right? To reduce the volume or to reduce the void ratio, right? Now, to reduce the void ratio, in the compaction, we need to add some water or the moisture within the clay, play some part, you know. So the moisture within the clay do something. So basically what happens, we do a standard compaction test, which is known as the standard Proctor test. So in the standard Proctor test, what we do, we have a mold, right? So then within the mold, we try to add the soil. So the basic idea is we need to add it in layer by layer. So we need to have it in 3 layers. So the size of the compaction mold is 1/30, cubic feet. So this is feet cube. And then what we do, we take a certain amount of samples, and within the samples, we add a certain amount of moisture. So let's say you have some soil, any kind of soil. You have it, you get the samples, and then you dry the samples completely. This is your starting point. Once you dry the samples, then you keep adding some moisture in it. And when you add the moisture, you get a certain moisture content. And with that moisture content, you do your compaction, the first level, right? Like this. So you add some soil and then you do the hammering. So the hammering can be done in the standard process. There is a hammer. Do you know the weight of the hammer?
25.
It's 2 pounds. So basically the hammer is 2-pound hammer, and it has a rise height of 1 feet. I think 1 feet or 18 inches, 1 feet. The small hammer. You can raise it and lift it, So it do 1 tap. So basically what you have to do is you need to do here 25 tap. Whatever. So 25 tap each time, 25 times, add more samples, do the second layer. So this is your second layer, compact it, do the third layer, compact it, done, right? So basically, a known volume and the weight, you measure it, right? So you can calculate the unit weight. And then you calculate the moisture content. So once you know the unit weight and then calculate the moisture content, you can determine the dry unit weight, gamma D, for these samples. So you calculate a gamma D for a sample 1. So let's say you got it for water content W1. So basically, let's say the W1 is 15 degree, 15% moisture content. All right. And for this, you get a gamma D of, I don't know, maybe 78 pound per feet cube. Okay. This is what you got. All right. Now you go ahead and make a plot. Here you have a gamma D, and here you have moisture content. And in this one, you add the first point, which is 78 and 15 degree. All right. Then on the same samples, you take the samples out, you break down the entire soil, and then you add some extra water. So when you add some extra water, you are increasing the moisture content 15% to maybe 17, 18%, So let's say you go to 18%. So when you add the 18%, you do the compaction, make another set of samples, test it again, calculate the gamma D, and let's say you get a gamma D of 81 pound per feet. All right. So you go ahead, get your moisture content, mark gamma D like that. All right. And then, so you need to repeat the same procedure again and again. You take the samples out, break it down, add moisture, compact it again, calculate the gamma D, and see what is the number. So let's say at 21%, we get a number of 84, 26. Okay, so the next number is let's say 25% and 30%. Okay, we're able to do this, and for each numbers we get like 80 and 74. All right.
Gamma D, since we are adding water.
Yeah, it's like we get a gamma bulk, then we calculate the moisture content to find out the gamma D. Okay. So basically so this is for 15, this is for 18, this is for 21, 25, and this is for 30. Okay. So for 21, we got 84, then 25, we got 80, 80 should be here, and then 74. 74 is somewhere here. Okay. Just like this. So basically, if we try to draw a curve like this, okay? It looks like this. So when we get this curve, we find a peak point, this name as OMC, and this is not the OMC, sorry. This, yeah, this is the gamma D max. Sorry. And this is the OMC, right? Right there. All right. So when you get the OMC and gamma D max, this is what we get from a compaction test. That's how it's starting from. Now, for this case, this is known as the standard compaction effort. You know, for this one, we are getting a number looks like this. Let's change the game. Now, up to here is okay. So basically, what happens as we add the moisture content, first it reaches to the maximum point, and then
It begins.
begins dropping. So why it begins dropping? Sure.
So is there any limitation of the free fall height? What will be the free fall height of it?
In the standard proctor test is standardized. So
So
everything is fixed. Your number of tap is fixed, your hammer weight is fixed, your free fall height is fixed, everything is fixed.
30 inch.
Is 30 inch?
Before height, probably, I'm not sure.
Probably not 30 inch. It's smaller. 30 inch is lower. When I did it, I can sit down and pull it. So most likely it's 12 inch, 1 feet. Most likely 1 feet. 12 inch. Okay.
It's for standard.
Yeah, it's a standard for a standard program.
For modified is different.
Yeah, I'm going there. But my first question is, when you do the moisture content, so your moisture content is increasing. So your compaction volume goes up first and then it started dropping. You know why?
Softening, due to the softening.
No, not at all. No way.
So, when the moisture increases in the, soil,
Uh-huh.
first of all, after that, the peak point, this, water goes into those air voids.
Okay,
That's why
I'm going there. First, why the moisture content increase, the gamma D is increasing. Why?
Because initially there is room for expansion for the, because water is incompressible material. So
Okay.
when it enters the soil particle, there is room for movement, I think. But after a certain point, the soil, the water will bound to move to the air voids probably.
Partially true. Partially right. I take it. Any other?
Gamma bulk is increasing.
Gamma bulk is increasing. If you look at that, the gamma bulk line is always going up. But gamma D line is going up after a point. If you draw the gamma bulk line is a straight line, it's just going up and up. No, zero to air part line is different. That's a different.
There is still void force there. So,
There is always white port left, no matter what.
Yes,
Okay, what is the purpose of the water here? In consolidation, what happens? The soil is fully saturated, you apply pressure, water got trapped, and then the water goes out, right? So water drains out. When the water drains out, it creates some rooms, so the soil settles, right? That is the consolidation. What happens in compaction?
From the compaction, the water doesn't always move.
get out.
Does water move?
No,
So no water goes out. It's a unsaturated test, right? It's not a saturated test.
water is still there.
Water is always there, no matter.
Like, water doesn't escape the soil, so the in compaction only the air voids gets compressed.
Yes, but why the air void was there at all time? You have the same compaction exposure at every time. But why up to a certain point you add the moisture? How many of you cook? 1, 2, 3, 4. Everyone. Kelechi, you don't cook?
I could,
You cook? What do you cook?
rice.
Right?
Yeah.
Have you ever added salt in the rice?
Yes.
You did? So let's say you add 1 teaspoon of salt. Is it okay?
Yeah,
How about 2 teaspoons of salt?
becomes salty.
Becomes salty. How about 3 teaspoons of salt?
It's all sorts. It's all sorts.
Is all salt. Can you eat?
No,
If you add water in the soil, it behaves like a salt.
You can absorb the liquid nature increases.
I cannot give you a better perspective than salt. In terms of compaction. You add a salt up to an optimum level,
adapt.
you get the best taste. After you add more salt, that's a poison, that's not a salt, that's not a taste. Okay? So what works in the soil is you add water, water acts like a lubricant, like a mobile. You know? So you need an optimum content of the lubricant. So every time when you compact it, you're hammering it, right? There is a friction between the soil. So they will try to counteract against your compaction force, right? The mechanical force you're adding. So it's not letting it compact it, being compacted. But if you add a certain optimum amount of water in it, that water will cut down the friction, internal friction, right? It behaves like it just creates a simple flame on top of the water, you know? So it's just good enough to readjust the soil particle. You know, up to a certain level, it's good enough to readjust the soil particle. As you add the compaction effort, it just readjusts it. Right?
When we're drying it, it's going away, right?
That's let you're not compacting.
I think it's related to friction, right?
Yeah, it's like it's the friction between the soil particles, you know. So and then when you add the water just creates a very thin film between the soil. So it's just cutting off your frictional resistance between the soil particles, you know. So and then it just do the readjustment up, and you need to find out the optimum level, your salt level for your test, right? You find it, you get it right. Got it? So that's the compaction. So what is the difference between the compaction and consolidation? Again,
In consolidation, the water drains out of the soil.
in compaction,
It remains in the soil, it traps in the.
but it's not about the trapping.
Is that, I think the process.
In the compaction, water acts like a lubricant. Always remember that. The primary job of water is being a lubricant, but we need to find out the optimum lubricant content. If we add extra, then it doesn't only act like a lubricant. Now you're compacting it, you have extra moisture in it. So then it's not allowing to compact more because it's trying to fill the void. It's trying to take the space. You know? So basically you need to have the moisture content that you can achieve at max. You know, the maximum amount of water that will allow to get to the maximum compaction. That's the optimum moisture content. You go beyond that line, the water will start taking the space. And that will not let you compact. So after this line, it's not letting you to compact. So it's behave in the opposite way. It also helps, but let's say it's allowing you to readjust, you know, cutting off the frictional resistance. But not only that, it also take this space. So soil cannot come closer because water is holding that space. You know?
So, what is the practical application of this optimum moisture content?
That's every artwork,
Every foundation design and
not the foundation design, every artwork, every field embankment, anything you build depends on this. This is the basic.
so we need to, we want to have the optimum moisture content and the maximum dry density.
Okay, now the question is, what happens in terms of your cohesion? You get your maximum cohesion, your cohesion curve follows like this, the same way. You get your maximum cohesion at this level. You know, your friction angle also follows the same trend. So you get your maximum strength when the soil has the maximum compaction. You know, that's the number one, but that's not the end of it. The big in the archetypal slope, the most important part is your permeability. Okay, so now in terms of your permeability, what happens there is another line. Looks like this. Anyone knows?
You have word like
Okay, 0 yard line. What is the explain me? What is the 0 yard line? Very good. Any idea what is the 0 yard line?
So it's all water.
No. Fully compacted, theoretically, the maximum compaction you can achieve. And you never achieve the max, you know. But in terms of your permeability, the cohesion goes up, you know. But in terms of your permeability, it has higher permeability line is always looks like this. The more compaction you do on the wet side, your permeability is going down. You know, or it should, the line should be opposite. I draw it in name. That's the conductivity. Basically, your permeability line follows the same trend. You know,
So more water content permeability will be less.
permeability will be less. So basically, for earth dam construction, you target this side. This is known as the dry side of optimum, and this is the wet side of optimum. So when you try to build the core, how do you recommend your compaction?
Wet side. Wet side.
Yes, your best idea is here.
Can you just explain it again?
Your permeability line follows like this. So if you do the compaction on the wetter side, your permeability is less than the drier side. Okay, so in the wetter side, your permeability is less because water trapped and water reoriented it, you know. So basically, it's trying to cut off your permeability. So it has more resistance.
It is the higher initial stage of the wetter side.
Yeah, it's like initial state of the wetter side, you get much higher, much lower permeability and higher strength too. You know, so in most of the cases, in terms of the earthwork, your recommended number is 98% compaction. 98% compaction, remember it. In some projects, they may allow you up to 95% compaction. So now the question is, what is the 95% compaction level? This is your 100% line, right? This is your 95% line. This is your 90%. So how do you calculate the 90% line? How do you calculate the 95% line? You know what is your gamma D max. So let's say for this soil, your gamma D max is 84. Okay. 100%. So 95% line. How do you calculate the 95%? 84 multiplied by 0.95. Can you calculate?
79.8.
So let's say this number is 79. 95% is 79?
79.8.
Of 84.
95 of 84. 6 drop. 84. 84.95. It should be for 81. Not 90%, 95%.
79.8.
Okay, 79.8, like 80. Okay. And then what is the for 90%?
75.6.
70?
5.6.
75.6. Okay. So basically what happens is like you find out to the 95% compaction, you get two numbers, right? So what is the range for dry of optimum? That's your moisture content.
High optimum and wetter.
So that's your moisture content permitted within the pre-construction. You cannot go beyond that.
Then on the dry side, we have to.
Yes, that's your dry of optimum. And then you also need to find out the weight of optimum. So this is the weight of optimum. So you find out what is the number. So if this is 21%, maybe this is 18%. Maybe this is 21%. Okay, and this is maybe 24%. Okay, so all you can allow within the field, you can allow in your borrow material.
So we are valuing 18% to 24%.
No. We cannot allow either. You can allow the weight of optimum, dry of optimum, or weight of optimum. For higher slope construction, do you need a dry of optimum or weight of optimum? For higher slope construction,
Right.
dry.
Yeah, you need the permeability.
You don't need the permeability. Permeability is not the concern. So you are on the higher dry of optimum, you get higher shear strength because you're on the drier side. You know, you are getting the weight of optimum, you get higher permeability. So on in terms of the dam and levee construction, you should be on the
Weight of optimum.
weight of optimum because you get
High permeability, so. the-
lower permeability. In the weight of optimum, permeability goes down. Weight of optimum, your permeability value is low. So this is for dam or levee. This is for the embankment. Okay, my signature.
Usually during construction of earthen dam, we need to borrow soil from a borrow pit.
That's the question. Yes. So
So usually there is a condition that the borrow pit water content must be equal to our target moisture content.
can I do that?
So it is not practically possible. So how to overcome this obstacle?
Okay, there are two ways. First of all, you need to find out what is your borrow pit. Find out the moisture content, where your moisture content is less than your target moisture content. So you can find out how much moisture you need to add. Got it? So you calculate what is the void ratio there. Let's say your initial moisture content is 10%, right? If your initial moisture content is 10%, you go there, you add additional, you want to reach 21%, compact it, and over there is 10% loose, you know. So what you have to do is you have to convert the 10% loose to 10% compacted, right? First, and then from the compacted to you need to convert it into the 21% compacted. From the loose to compacted and compacted and compacted, right? So that's how you do it. So you calculate what is the amount of water needed for that. That's one way. Okay. If your soil is dry, wet, you cannot do anything. You cannot take out the moisture from the soil, right? You cannot slow down the project, right? So if you cannot slow down the project, then what you can do? You need to achieve this number. So in your design, your designer is giving you the room of this, but in between 84, 79, and 84, right? So you need to achieve it no matter what. If you are not able to achieve it, you have to scrap everything and redo the construction. So the contractor will lose money. They won't get paid unless they achieve that compaction level. Right? So how do you can get a certain level of compaction there? Any idea?
Can introduce foreign materials. We can introduce foreign materials with the soil.
How you do the quality control then? Because you don't know what permeability is going to be. isn't it?
When we change the system and
So actually.
Yeah.
Using the roller carefully.
Very good, yes, that's the only thing you can do. You need to add more compaction effort. If you have more moisture, this curve is valid for a certain compaction effort. If you add more compaction effort, what will happen?
more dry intensity.
You get a higher dry density, right? If you add more compaction effort. If you even add more compaction effort, it goes up, right? So if you want to achieve, let's say your moisture content is 30%. Given moisture content 30%, you really cannot achieve here, right? So maybe you still need even bigger. So you need much higher convection effort to achieve that unit rate.
But there should be some kind of practical range. I mean, what is the tolerance? I mean,
Yeah, that's the tolerance. I'm giving you the tolerance. The tolerance is here. I'm not giving you 84%. I'm giving you up to 80%.
maximum limit is 80%.
Maximum limit is
If the required limit is more than if the existing soil has moisture more than the 80%, then we cannot reduce it to, it's not practically feasible.
no. You cannot reduce it. You cannot reduce it. No way. So the only way you have is to do it more compact. You need to increase your compaction effort. And contractors don't like that. Because that slows down the construction and it increases the cost.
But if we introduce some kind of, if we increase the efficiency of the filter material used here, I mean, the soil has more moisture, okay?
No, first of all, your design, your construction is not according to the design. Filter material comes later. There is nothing to do with the filter materials here. First of all, you did a design with a certain, you are considering a core at the middle. The core is supposed to block your water flow, right? But it will behave as per the design if you construct it as per the design, right? If you cannot construct it as per the design, then you have nothing to do, right? So you can use a very good materials, but you are not achieving the compaction what you can expect. With the same material, with the 85% compaction is here, right? What permeability you can get? You'll have more void in it, no matter what, right? So it will not behave the way it should behave. So you can expect the maximum efficiency of the construction materials if you can do the compaction at this level. So let's say we don't have the perfect scenario of what is our target moisture content, we can have it. So basically all we have to do is we have to readjust our compaction. Okay. Any question on compaction? Okay, good. That's it. We're done. Thank you so much. Good luck with your everything. So you have, and I'm done with my semester.
We automate two down paper, two down, but we two homeworks.
What course will you take in the next week?
Competition based.
Three down. Okay.
Need to, register for spring.
We'll do that. All right. Good luck.